So what is this? Essentially, we have these deep dive presentations that we do at R&D internally. It's a way for us to build context between teams, between our engineering, science, product teams. And we went through one of these deep dives last week, and we decided that it'd be a really good opportunity to do some more context building with our community, which is a community that is diverse in itself. We have members from the blockchain community, as well as members from ecosystem service community or climate change communities and science communities. So we decided that we would go ahead and give this presentation again to our community as a larger audience to do some context building. And so this is the lineup today that we're going to go through 4 parts here. The first part will be covered by Corey. We're going to talk about Regen Ledger and understanding blockchain. What is blockchain on a general level? Some of you might be veterans here, but we are doing that context building for those of you that are less familiar. That's going to lead into this part 2, where I'm going to present on, which is understanding the ecocredit module in a little more detail, the different parts that make up the ecocredit module. Part 3 is going to be led by Sam, and we're going to talk a little bit about the relationship between ecocredit module, how it's being used with the registry, and how it's being used with the registry, and kind of looking ahead in part 4, which will be broken up between all of us to give a little outro on what's on the horizon. So without further ado, I'm going to hand it off to Corey to get started off.
Cool, thanks, Ryan. Yeah, so let's talk a little bit about what Regen Ledger is, and starting off, probably makes sense to give a little bit of background context on blockchain. Go to the next slide. So for the purposes of this, let's all set a kind of common understanding and framing here for what a blockchain actually is. At its core, a blockchain is a replicated deterministic state machine. So what that means is that there is a progression of state, right? Some internal state application logic that updates over time. The way that updates is through state transitions, where there's a transaction that is sent to the network, and that triggers, let's say, the application state to go from, previously it said that the account balance sheet was X, and now it says the account balance sheet is Y. An important thing about blockchains is that all of the state transitions that come through transactions are all cryptographically signed, which means the only way that the application system can actually update its state and progress over time is through authenticated messages that individual end users are signing onto the network. And all of these messages, in terms of how they're structured on the actual computers and servers, is that they're assembled into what are called blocks. And certain people who are running the software will, when they assemble a bunch of transactions into a group and call it a block, they will then sort of solidify it, a process called minting, and then send that block around to all of the other peers in the network. And so it's from this that we get the notion of a blockchain. It's literally a chain of blocks where each block is a set of transactions of these state updates. And so blockchains have several qualities that are exciting for us, Regen Network. If you think of us as a project whose mission is to be a global accounting system for ecological health, as well as climate finance, there are 3 kind of really important qualities of blockchains that I think are important to talk about here. One is immutability. That means that all of the data that's being landed on the blockchain, all of the state updates that we were just talking about before, they can't get reversed. There's no way to go back in history, and there's no way to sort of change the state to sort of rewrite history or remove that an action happened in the past. Another thing is that it's publicly verifiable. So as I mentioned, every single action that happens on a blockchain network are all cryptographically signed transactions from end users. And so with that, when you're looking at all of the state transitions and all of the, the data on the blockchain, with every piece of data that you're seeing, you're able to see where it came from and who actually sent that data to be there. And a third component is that it's decentralized. And one of the common benefits of decentralization that I think is worth talking about here is censorship resistance. So there isn't a single person or a single entity or server infrastructure runner who could take down their software or their servers and shut down the whole network. Because it's a peer-to-peer network, people can join the network at any point in time. They can participate in validating blocks. And because of that, it's quite difficult unless all of the people validating the network in a coordinated way choose to go offline. So that censorship resistance is also something that is valuable for us in our use case. Next slide. So another thing that you'll probably hear commonly in the blockchain ecosystem is proof of stake. I think it's worth to just give a little bit of context for what this is. Proof of stake and proof of work are two different consensus mechanisms for a blockchain. So they're describing actually how does the different nodes in the network come to alignment on what the next block in the chain should be. In proof of work, the way that these miners are actually deciding that is that every single miner is given some proportional voting power on determining what the next block will be, proportional to their computational power. So they're essentially spinning CPU cycles as fast as they can in an arms race, and whoever is winning the arms race is going to have the highest probability of minting that next block. And in proof of stake, rather than having minting probability proportional to computational power, we have it proportional to staking tokens. So in our case, that's the native Regen token. And there's a few concrete benefits of proof of stake blockchains. The ones that I think are worth calling out here are that, one, it's drastically more environmentally friendly. So there's no wasteful compute cycles where they're just trying to spin CPU cycles in an effort to solve a meaningless, hard computational puzzle. And the other component that's interesting for proof of stake networks is that it gives the token holders governance over the network. So not just the validators who are actually running the infrastructure get to have their voting weight be added to their probability of minting a block, but individual end users who hold, let's say, Regen token can delegate their token weight or stake with a validator, thus increasing that validator's voting power and participating in on-chain governance and choosing kind of how the network progresses. So now talking a bit about Regen Ledger. Regen Ledger is a domain-specific proof of stake blockchain application that's built with the Cosmos SDK. We can talk a little bit about what these terms mean. So I think this diagram is useful to look at. At the top, you see Regen Ledger, right? We're going to have a bunch of, within the context of Regen Ledger in our, quote unquote, like code base, the repository for Regen Ledger, we have a lot of domain-specific modules and functionality. This is where we're able to design what are the things that are critical to our use case of ecological health and regeneration that we want to encode into the actual, into the software. Underneath that, there's the Cosmos SDK, which is a blockchain application framework that provides a bunch of modules as well that are more commonly used for all sorts of other blockchains in our ecosystem. This provides functionality around staking and governance, things that a lot of proof of stake blockchains are going to want to use. And so we're basically building on top of that. And then underneath that, you have this layer where we're using the Tendermint consensus engine for networking and consensus. So the actual peer-to-peer communication, the circulating of blocks between peers on the network, that's all happening, not at the Cosmos SDK level, but a layer underneath that using this library called Tendermint. Next slide. And so to talk a little bit about what domain specificity means and why we've chosen that, Gregory's written a great article on this on our Medium, which you can go ahead and read. I've linked to it here in the deck, and I think we should be able to send a link to this deck after the webinar. And what he describes is that our approach is a hybrid of sort of two potential paths for proof of stake networks. On one hand, you've got community-specific networks where really, you're just distributing a bunch of tokens and you're saying, let's let the token holders decide through governance what they want the network to do and what they think the purpose of the network should be. On the other hand, you could have an application-specific network where you're being really concrete about what the software features are going to be for this network, and you're wanting that to kind of bring users together and drive adoption. And for us, we see Regen as kind of a hybrid of these two models. We as R&D Inc., are very opinionated about the kinds of functionality that we think Regen Network should have, but we actively want to invite the community into that governance process, and to really have it be a conversation, and eventually to have it be a situation where it's not just us being the only developers of the network, but there are community contributors who are also putting in their own governance proposals and contributing with software upgrades. So we've chosen a domain-specific blockchain rather than building on top of an existing blockchain, Ethereum. And another reason for that is because we want our community to have control over the entire software stack. If we were doing a project just on Ethereum, it would be very difficult for the Regen project to have a say in, let's say, how gas fees are processed, or what the different auction bidding processes are for transaction fees and stuff like that. So yeah, next slide. And so, we mentioned earlier that Regen Network has Regen Ledger has its own specific set of modules. Here we can get an overview of what the different modules are on the actual Regen Ledger. We have 3 modules right now that are built into the Regen Ledger software repository: the ecocredit module, the data module, and the groups module. We're going to be focusing on talking about the ecocredit module today, mainly because that's the one module which is going to be enabled in the upcoming on-chain network upgrade that we're going to be putting a governance proposal for soon. So yeah, we're going to go into details on the scope of that and what the feature set is. And then what you're seeing is that each of these 3 modules sit alongside a whole slew of other SDK modules that are more common amongst a lot of SDK chains, with features around staking, around a bank module, which provides basic functionality for the Regen token itself, and governance. And then underneath, all of these modules are wired together and are able to kind of communicate with each other, maybe send data back and forth through each other. But you should think of each of these modules as basically their own little state machine. Each one has its own application state, has its own set of messages that it accepts from end users, and its own way of processing and managing some internal state. And I'll pass that to Ryan now.
Great, thank you, Corey. So in this part, I'm going to talk about the ecocredit module in more detail. As Corey mentioned, just as a little introduction, the ecocredit module is going to be the first module that is going to be a domain-specific module built into Regen Ledger, available on Regen mainnet. The other modules are available on a experimental test network, but this will be the first module that will be on mainnet. So it's really exciting. And yeah, in this part, we're going to go in a little more detail in understanding the ecocredit module. So what is the ecocredit module? Well, Corey also talked about modules. Their ways of defining state and how internal state can be updated. And the ecocredit module is focused on the state around ecosystem service credits. And ecosystem service credits can be a variety of types of ecosystem service credits. So there is no focus on carbon credits alone. We wanted to build a module that was adaptable and works like a framework to support different types of credits, including biodiversity credits and soil health credits, and basically anything that's an ecosystem service that people can come up with. And the credit class is going to be the primary abstraction of ecosystem service credits. And this is essentially used to manage the issuance process. And credit classes are managed by admins, and they have issuers, and the issuers issue credits in the form of credit batches. And we're going to go into detail on how all that works by looking at some of the data structures within the ecocredit module. So first off, credit classes, as I mentioned, this is the primary abstraction for ecosystem service credits, and credit classes are used to manage the issuance process. On the right here, we have an overview of what the properties are for a credit class as represented on chain. The first property there is class ID, and this is an auto-generated unique ID that is constructed from the credit type. So C01 in the example on the right is just a representation of what a credit class ID might look like, and that takes the abbreviation from the credit type, the C abbreviation, and 01 is the sequence number within that credit type. So this is the first credit type or credit class created using the carbon credit type. if you're asking what a credit type is, we're going to go into that on the next slide. Yeah, next up, we have the admin. The admin is responsible for managing the credit class. The admin has the capabilities of updating the issuers list, as well as updating the metadata, as well as changing the admin role over to another address. In this example on the right, we have a Regen address representing the admin. There's only one admin for each credit class. After that, we have the issuers. There can be any number of issuers for a credit class. Issuers are responsible for issuing credit batches. We're going to look at what a credit batch is in more detail in a few slides. But on the right here, we have an example of a couple addresses that are listed as issuers. And then after that, we have the credit type. The credit type, as I mentioned, is something that we're going to talk about here soon, but it essentially is used to create the class ID in each credit class. When it's created, it needs to use an approved credit type that is going to be defined as an on-chain parameter, or within a list of approved credit types is an on-chain parameter. And we're going to talk about parameters as well in this section. So we'll get to that. But yeah, each credit class has a credit type. And in this example, the credit type is the carbon credit type. And in addition to that, we have the metadata. Metadata is a 256 byte array. This can be used to store a small amount of information, or more likely, it could be used to support a content hash, and that would point to a larger amount of information. That information most likely will be defining the methodologies associated with the credit class. And in the example here, we just have a content ID to the right. And then finally, we have number of batches. So within the credit class, it's going to track the number of batches that have been issued from this credit class. And that's a general overview of the credit class. Next slide, we're going to look at the credit types. So what is a credit type? Well, credit type is the primary indicator used by a methodology to measure the change or impact resulting from an ecosystem service. We are starting with an initial default credit type. I mentioned there's a list of approved credit types that will be an on-chain parameter, and the initial value within the list will be a single carbon credit type, which is the credit type that we're planning to use for the Regen Registry program. The credit type, in terms of its data structure and properties, it includes a name, an abbreviation. An abbreviation can be 1 to 3 characters long. The measurement unit, which is more details about what is actually being measured, in this case, metric ton CO2 equivalent, and a decimal precision, so how precisely it's being measured. And yeah, the credit type is something that needs to be included within the credit class when the credit class is created. And when the credit class is created, it can only use an approved credit type that are listed in the on-chain parameter for approved credit types. So next up, we're going to look at credit batches. And as I mentioned in the first slide, so credit batches are essentially how credits are issued. And within a credit batches are issued by issuers of that credit class. And so looking at some of the properties within the credit batch, we are starting with the class ID. This is the same representation that is in the credit class. So when a credit batch is issued, it stores information about the class that it's being issued from. The denomination, this is essentially the token denomination, but a credit denomination in this case, where it's constructed using the class ID, as well as the start and end date, or the vintage, the period in which the ecosystem service was monitored and measured. And it includes a sequence number at the end of it, which is the sequence number for this batch. So in the credit class properties, we had a number of batches was one of the properties. And essentially this would be the first batch issued from the credit class C01. And each batch will have this unique denomination with that includes the start and end date. So next up, we're going to look at issuer. That just records the issuer that was responsible for issuing this credit batch. As we have in credit class, there's also a metadata field. This can include information about the monitoring process or the data accumulated from the process. And once again, that's a 256 byte array that can be used to store a small amount of information or point to a content hash. The credit batch also keeps track of the number of active credits that have been issued from this credit batch. That includes tradable credits as well as retired credits. And then it also tracks the number of canceled credits. So it is possible to cancel credits that have been issued. Then it also includes the start and end date, which is included in the denomination, as well as the project location. And the project location is constructed from the country code, the subnational code, and the postal code. And it's following the ISO 31662 standards. But all that information is included in each credit batch. And yeah, I think that covers this slide. So I'll just move on to the next one. Life cycle of a credit. Okay, so as Corey mentioned in the first part, there are these transactions that perform straight state transitions. Within these transactions, there are messages, and within the ecocredit module, the defined messages or functionality that is used to update state, ecocredit module state, include the ability to create a class. So there's a message create class, the ability to update the credit class. These are the functions that the admin is responsible for. So that's updating the admin role, updating the metadata, updating the issuers list, as well as a message for creating a credit batch. And that's what the issuer is responsible for within a credit class. And then there's also the ability to send, retire, and cancel credits. And something important to note here in relation to creating credit batches and sending credit batches and retiring credit batches is that credits are either tradable or retired, and they're tracked for each account as either being tradable or retired. Once credits are retired, they can no longer be unretired. Essentially, when credits are retired, it implies that the holder is claiming the credit as an offset. And credits can be retired in 3 different stages, essentially. So when you create a credit batch, you can list credits that are going to, or you can specify a number of credits that will be retired upon issuance. So when you create a credit batch, you can create a credit batch with tradable and retired credits included. You could retire all the credits upon issuance. You have the option to specify how many credits will be either tradable or retired. And this is also possible when you're sending credits to another address. So if you're the owner of credits and you have, say, 20 tradable credits, you want to retire 10 of those credits upon transfer to another account. So you can send 10 tradable credits and 10 credits that retire upon transfer. And then obviously the other option is to retire the credits when you are the holder or owner of a certain number of tradable credits. You have the option to retire credits. So this is the functionality in an overview of how the credit lifecycle works. And the functionality is these messages here listed at the bottom in terms of this is how state within the ecocredit module is updated. As I mentioned when I was talking about credit types, there are these on-chain parameters. Each module has specific on-chain parameters that can only be updated through a governance process. So there's a parameter change proposal that's submitted, and actually on Regen mainnet, we've already had 3 parameter change proposals go through. One was the enabling IBC transfers, enabling token transfers, and another one was the increasing the max validator set. So we've already gone through 3 governance proposals for updating parameters, and these parameters within the ecocredit module would need to go through the same proposal process. The 4 parameters within the ecocredit module include the credit class fee, This is the fee that's charged when a credit class is created. The allowed class creators. So we're going to talk about this on, I believe, the next slide. That the allowed class creators is a list of addresses that are able to create credit classes. And this can be either enabled or disabled on a network. So that brings us to the next parameter, which is Allowlist enabled. This is going to be set for true initially on once Regen Ledger 2.0 has been, or once Regen Mainnet has been updated, Regen Ledger 2.0. And the final parameter there is credit types, which is what I started with at the beginning. There's a list of credit types that have been approved, and this default credit type that's going to be starting on that list is going to be the carbon credit type. And in order to add another credit type that is usable when you want to create a credit class, you're going to have to go through this parameter change proposal process and submit a governance proposal to add, for example, a biodiversity credit type. Okay, so credit class creator allow list. This is something that can be either enabled or disabled, as mentioned on the previous slide. And this is intended to be a temporary feature, essentially, on Regen Mainnet. The idea here is that we're aware that there might be some changes to the ecocredit module in terms of how the data is structured, that we want to make sure that anyone who's creating credit classes and issuing credits is willing to work with the Regen Network Development team and the community on the migration process once there is an update in terms of how the credit classes need to be represented, like if new data needs to be added and filled in. And so we want to make sure that there's a good user experience. So we are certain that the ecocredit module is ready for mainnet, but we are also aware that there might be some minor changes that we need to make. And so we need to be working with anyone who is creating credit classes. And this was proposed as a solution to go with this permissioned approach that would allow for credit class creators to only create, or allow for people to only create credit classes if they're on this list of approved credit class creators. There are some guidelines that we've created, and R&D plans to go through the same process that other people are being asked to go through. These guidelines are included in our governance repo that we created to draft proposals, governance proposals. And this is a document called Process for Becoming a Credit Class Creator. And this includes information such that if you're either an applicant interested in becoming a credit class creator, or if you're a community member wondering how you should properly vote upon or judge people that are applying, then this document provides some more information. The main key points here are we want people that are actively engaged in the design and development of ecosystem service credits. We want people that are going to demonstrate their desire and capacity to work with the Regen Ledger team and maintainers, community, when and if the credit class data changes and we needed to do some migrations. And then also we want people to socialize their candidacy in the forum and gather initial support before submitting a proposal. And there's more details about that, as I mentioned, in the governance repo in this document called Process for Becoming a Credit Class Creator. And then, okay, how do you interact with it? Essentially, there are a couple options here for developers. We have the command line interface. If you're comfortable with using the CLI, the ecocredit module, you can use the command line interface to interact with the ecocredit module, as well as query information from the ecocredit module state. And on the example on the right here, we have just an example of what some of the transaction methods are, which are representing essentially what we talked about in terms of the messages that are available and a couple helper functions. I guess the gen batch JSON function is something that helps you create a credit batch because there's a lot of information that goes in there. So, but yeah, there's the command line interface available, which is using the regen binary. And then also we have gRPC and REST API endpoints available for third-party developers wanting to build GUIs or dApps. Then also in the future, we're planning on building out our own web app or our registry application in order to support the managing of issuance and custody of credits. So that is something to look forward to for people that are not as comfortable with using the command line interface, or that are not necessarily looking to build an application themselves, but to be a general user using a interface built by the Regen Network Development team. And that brings us to the end of part 2. So I'm going to go ahead and hand it off to Sam now.
Cool. Thanks, Ryan. So yeah, now that we've talked about the ledger and the ecocredit module and how different actors can engage in managing on-chain assets, I'll speak a bit more to how the ecocredit module can be used in the real world. So how registries, project developers, land stewards, and other organizations might use the ecocredit module to represent credits that are being issued to conservation or restoration projects. Next slide, please. Yeah, and so I'll start by just talking a little bit about how credits are created. So if you have a project or you're taking part in ecological restoration, what do you need to do to get issued a credit? So to properly get rewarded for ecological regeneration projects or fund the adoption of new land management practices, land stewards must provide evidence to prove how their environmental stewardship helps conserve, restore, or regenerate landscapes. And traditionally, this work is done using an ecosystem service registry. So registries are organizations who work with land stewards to measure changes in ecological state to provide payments for ecosystem services such as carbon credits. So examples of these groups include Vera, Gold Standard, Nori, or our own Regen Registry. And at a high level, what all these groups are doing is we're working with land stewards to help bundle their work into a report which can provide evidence for credit issuance. Walking through this process a bit more, we typically start with registration, where the land steward or the project developer will select a methodology which provides the details for the monitoring, reporting, and verification process. They'll check the project eligibility requirements outlined by the registry program or in the methodology. They'll develop a project plan that defines what they're doing, their practice, how they're doing it, and the different actors that are involved. And then they'll establish a baseline, which essentially says, at the beginning of this project, this was the current state of the environment, so that in the future, we can reference that to help measure ecological change. So once the baseline is established, we go through the monitoring, reporting, and verification process, which happens over the course of the project duration. So typically how this works is the project developer or the land steward will monitor the changes in the ecological state. So maybe they're measuring carbon sequestration, reforestation, improvements in water quality, and they'll develop a report, which they then provide to what's called a verifier. And so the role of the verifier is to double check the work. That might be going through the report itself in a desk audit. They might be performing an in-field visit to collect their own measurements and cross-reference those to see if what's being claimed is actually happening. The verifier produces their own report, and then they submit that to the registry. And so the registry is checking both these reports to see if there are any discrepancies between what the different actors are finding. And if everything checks out, they'll go ahead and issue credits. So the registry will issue credits to the project proponent. This could be the land steward, this could be a project developer speaking on behalf of the land steward, or another trusted third party. And once the project proponent has those credits, they can do a bunch of different things. They could retire them, they could list them on the registry for sale, they could give them to a third-party broker to sell them, and then they'll transfer those, and maybe they transfer those to a buyer or another person. And so if a buyer wants to hold these credits and claim them as offsets, typically they have to create an account on that registry and then submit a request to retire those credits. Next slide, please. So as you can see, a lot goes into this process, and there are a lot of steps that land stewards have to go to receive payment for ecosystem services, and a huge paper trail between registering the project and actual issuance of credits. There are also a lot of different actors involved, and the registry has to play a really big role in making sure people like the project proponent, the methodology designers, the monitors, the verifiers, auditors, and buyers all work together to ensure project legitimacy and make sure that credits are created, issued, and retired in an accountable way, so we can avoid false claims and issues like double counting. So why use a blockchain ledger? As Corey mentioned before, there are a lot of different advantages. They're immutable, publicly verifiable, and decentralized. They provide the infrastructure to share in-field measurements, digital management records, credit and methodology information, and reports on an open access digital ledger. With the launch of the ecocredit module, we're doing two big things. We're decentralizing the management of on-chain assets and ecological assets, and we're starting to digitize the long paper trail of information which goes into a claim and storing it on an immutable ledger such that a wider set of actors can help evaluate and come to an agreement around claims. Next slide, please. So as I said, the first thing the ecocredit module allows us to do is begin a decentralized credit management. So ecosystem service registries are typically the ones that are going to be issuing and managing the assets and making sure that transfer and retirements and sometimes cancellations of credits are happening correctly. What we're doing is a little bit different, and we're introducing a new set of actors. So this is the same slide that I showed a few, same flow I showed a few slides ago, but a little bit different. So on the left, you can see the project lifecycle, where a land steward or project developer will register a project, submit documents, establish baseline, and monitor changes. And at the end of that, they're ready to get issued credits. While a registry typically might issue them to them directly, what we're doing is introducing the credit class creator, administrator, and issuers who are going to do that for them. So credit class creators will create the credit type that's going to be, that represents what the type of credit that a land steward is trying to get. The credit class creator will set an administrator and a set of issuers who will mint new batches of those credits on behalf of the land steward. When they issue those credits, they can issue them to a variety of different actors. They can issue them to the land stewards themselves. They can issue them to project developers or another third party that's speaking on behalf of the land steward. They can issue them directly to the buyer. And they can also issue them directly into a retired state or a non-retired state. Similarly, buyers and credit holders are now able to transfer and retire credits without having to go through a third party. So they have more autonomy of managing on-chain assets. So if a buyer wanted to claim those offsets or transfer them or retire them, they could do that directly without having to put in a request to do that thing. So in terms of who would be a credit class administrator or creator or issuer, this could be a variety of different actors. It could be the registry that's creating credits on the land steward's behalf, but the responsibility could also be delegated to a trusted third party or an interested party. So a methodology developer or a project developer, which typically works with a single type of project, might want to take on administering and issuing credits and managing those assets. Similarly, if we have lower tier credits like community composting credits, it could just be a set of community members interested in engaging in an ecological regeneration project and financing those in unique ways. And so what the ecocredit module is doing is it's the first step towards decentralizing the system. Next slide, please. And so the other thing we're doing with the launch of the ecocredit module is we're starting to digitize information related to ecological claims. Before, a lot of this information was stored in PDFs and relatively little bit of it was machine readable. Storing information about these claims in a digital way provides a lot of advantages to providing the transparency needed for open evaluation of claims and curation of assets by allowing us to treat on-chain representations of all these different elements. So on the left, you can see the credit class that Ryan was speaking about earlier. And on the right, you can see a mock-up of what it would look like to start to digitize some of these processes. So within each of these sections, there might be a set of information, but you could be storing information about the credit class or the methodology or the project itself and events related to that project. So if a land steward uploaded a set of data, that could be stored as an element on the ledger, which helps advance our understanding of the relationship between ecological restoration, and these kind of claims. Next slide, please. And so with the ecocredit module, we're including this element of metadata. And so that is a general descriptor for the type of credit that's being traded. And so typically what that looks like is it's going to be a PDF or some sort of off-chain element that describes the type of credit. Next slide. So the credit class metadata can list information about the credit definition, the project eligibility requirements, the GHG accounting procedures, and verification requirements. So whether or not additionality is included, whether or not that type of credit allows for things like aggregate projects, and maybe information about what methodologies are allowed to be used for that type of credit. Next slide, please. And so where does the Regen Registry fit in? So ecosystem service registries, as I mentioned earlier, typically help land stewards and project developers generate reports to create ecological assets. They manage those assets on behalf of buyers and trusted third parties. And they also provide a platform for scientists and researchers to work together to create methodologies, which can actually measure changes in ecological state. But the Regen Ledger is designed to be an open platform for the creation of assets. And so rather than having a single registry manage everything, we're trying to decentralize or create a decentralized system where the public can help manage, assess, and curate claims. But we know that this won't happen overnight, and it's going to take a lot of work to get towards that vision. So the Regen Registry hopes to be one of the first actors in this system. Like other registries, we provide pathways which help land stewards, project developers, and science create and manage on-chain assets. But we also want to lead as an example of how other registries and groups can interface with the ledger. So hopefully methodology designers and project developers and other climate action organizations can see the work that we're doing and how we're doing that and get excited about contributing to this project. Next slide. So what's on the horizon? Next slide. So with the launch of the ecocredit module, we hope to showcase how it can be used to trade ecosystem service credits. The Regen Registry hopes to get voted in as one of the first credit class creators. And in doing so, we're going to be issuing credits for our historical vintages. We're also going to be brokering credits from other registries, such as Vera and Gold Standard, and digitizing them to show how the ledger and ecocredit module be used by others. We also hope to build tools for people to interface with the ledger and the registry directly so that you can manage and view your credits and create new assets without having to go through a command line interface. Finally, this is all working up towards opening up so it's not a permissioned approach. Right now, it's a permissioned approach while we kind of get our feet on the ground and work through the bugs. But in the long run, we want other people to be able to do this in a permissionless way. Slide.
Cool. And on the ledger functionality side, we can talk about what are the future features planned for the ecocredits module. Upcoming first is going to be the ability to list, buy, or sell ecocredits. So we actually have plans and there's specifications for this already in progress for how we can build into the ecocredits module itself the ability for an owner of ecocredits to, let's say, list them for sale for a certain type of IBC-enabled currency. That would likely start with, potentially Regen or IBC-enabled stablecoin. But I think the initial hope is that this would be kind of filtered through a governance mechanism, so that there were an initial allowed set of currencies that that ecocredits could be sold for. Then also transferring credits across multiple chains, so bridging solutions. Our team is actively kind of looking at the Cosmos ecosystem and trying to stay close to the work in the Gravity Bridge and other IBC bridging solutions, so that we can try and ensure that ecocredits are able to move across different chains. Then also integrating with the data module for digitally signing claims that pertain to an ecocredit. The data module is intended to be a pretty open technical solution for for making attestations about, let's say, ecological health or other statements about data that may pertain to a project, and the ability to for users, regardless of whether or not they're the user who, let's say, put that data on chain, to be able to sign and sort of attest to the truth of that data. And lastly, on-chain smart contracting solutions like Cosmosm, so that we could have things like custom escrow accounts or potentially programmatic issuance of credits based on, let's say, thresholds of certain signatures in a data module. Next slide.
Great. This last slide is focused on community engagement. So we are wanting to iterate on the ecocredit module and improve it based on users' needs. And as we mentioned earlier, the ecocredit module will be the first module that's going to be on Regen mainnet, but we do have testnets available to experiment with the ecocredit module as well as the group and data module. And there are opportunities to use these modules together. And so we wanted to provide them in a experimental testing environment. So we have the Hambach test network, which is our experimental test network, DevNet, that includes these early versions of the group and data module, as well as the ecocredit module. And then the Redwood testnet, which is a stable version, essentially a duplicate of the configuration and everything that Regen mainnet is running on with a lower voting period, where you could test out specifically the ecocredit module without using live funds. And also there's a lot of fruitful discussions that have grown out of the signaling proposal posted in the forum. And there's been a lot of activity and a lot of really thoughtful responses. And we would like to continue to encourage people to use the forum as a way to express ideas and to discuss opportunities for interoperability or improvements on the ecocredit module and things like that. The signaling proposal is getting, that particular post or thread is getting quite long, so feel free to open up new threads in different areas and new ideas. But yeah, we would really like to encourage people to use the forum as a way to continue discussing ways that they're planning on using the ecocredit module, ways that they can improve it or integrate it with other projects. And then finally, we do have a grants program that's being spun up, and we have a lot of grant money that we would like to distribute to community members who are interested in building out features or researching integrations. And so please get in touch with us either in Discord or on one of the channels if you're interested in a grant working on something related to the ecocredit module. So yeah, we look forward to building the ecocredit module and improving upon it with the community. And yeah, we would like it to be a community effort as much as possible. So that brings us to the end. We have about 10 minutes left.